So we're looking at trig identities, and this is not going to be from the workbook per se. We're going to look at some of these, and then we're going to press pause for a day. I'm going to be turning you loose and gradually giving you a few more identities. You also want your formula sheet handy, unless you've memorized all those handy-dandy identities. I have not. So you want your formula sheet handy, either the yellow one or the gray one. Remember, the gray one you can write on. The yellow one you must leave pristine for the test. In fact, I think I told you the only thing that you were allowed to write on it was don't write on it. All right. And all I'm going to do, Trevor, is cut and paste a few identities for practice, and then I'm gradually going to give you a few more tricks of the trade. So as a heading, if you're wanting to write a heading down, you could write down something like Lesson 6, Part 2, the conjugate, if you're someone who likes headings, because I'm going to eventually show you a trick called the conjugate today. But for starters, I am going to try clip this one right here. I think I'll make it larger so you can read it at the back. It's number 5 from your Hints for Identities sheet. Yoink. Okay. Prove that. This one I think is going to turn out to be fairly quick. It's going to be about a 4-liner. And to prove it, I always draw a line like this. Here's our T. And I know I can't cross left and right side. Here, I'll make it a proper T. I can't give you, here's a series of steps, Brianna, that'll get you there every time. There's a science to trig identities, but there's a bit of an art to it. Suddenly you'll start to see stuff. Your brain will start to make connections. What I will do is give you an approach that if you do follow it step by step and you don't make any dumb math mistakes, you'll get there. You may not get to the end in the fastest way possible, Brett, but you'll get there. And the fastest way will come with practice. So, I think hint number 1 I wrote on that sheet was begin with the uglier side. I think I'm going to spend most of my time maybe working with this, or maybe not. I'm not sure. Hint number 2 was if there are more than 2 trig functions, 1, I see a sine, 2, I see a cos, 3, I see a tangent, 4, I see a secant. Is there more than 2 trig functions, Spencer? We're going to rewrite everything in terms of sine and cos. This is good. Tangent, in terms of sine and cosine, we learned this last day, is what? That's one you want to memorize, even though you technically don't have to. By the way, if I put a theta there, Mr. Dueck, will I lose marks off? No, if you put nothing there, because some kids get lazy and they just start doing that, there you will lose marks, as a matter of fact. Every year when I was marking the old provincial exams, there would be a batch of papers came through where none of the kids had bothered putting the thetas in. And I went, oh, that poor teacher hasn't read the exam specifications, has told their kids it's okay, and we have to take off a half mark each. Ah, it's disgusting. Minus. Secant is what in terms of sine and cosine? Now, the other thing that I'm always doing, Dominique, is I'm moving my eyes to the left, to the right, to the left, to the right, looking at the left side, looking at the right side. For example, what's on the bottom on the left side here, Dominique? What's on the bottom on the right side here? That's a good thing. That's a good thing. On the left side, I have 1 big fraction. On the right side, I have 2 small fractions. So even though my hint number 1 said begin with the more complex side, which was this, I think I'm going to do most of my work here. I think a logical approach would be write this as a single solitary fraction. How would I do that? Well, I'd find a common denominator. I have a common denominator already. In fact, if I write this as a single solitary fraction, my common denominator would be cosine. And in fact, I think the top would just be that minus that, and lo and behold, I'm done. Sadly, I probably won't give you one that easy on your test. Maybe as a multiple choice, but probably not. Sadly, they're going to be much more like, well, let's try a few more. $13. If you're copying it out from your sheet, or you can copy it from here. 13. Sine beta plus tan beta all over 1 plus cos beta equals tan beta. Ellen, which side do you think I'm going to be spending most of my time on? Left. In fact, even though I know I'm going to be spending most, this is why I said there's kind of a science and an art to it. The art part would be saying, you know what, write that as sine over cos, do that first and quit, and then you're done. So I'm going to do that first. Sine beta over cos beta. And now I'll begin with the left-hand side and spend most of my time there. How did I know to write it as sine over cos, Alex? 1, 2, 3, 3 different trig functions. It's probably worth my while. Sometimes when there's 2 trig functions, you still will, but I always pause, because if there's only 2 trig functions, maybe one of your Pythagorean ones from the top page will make things easier and stuff will cancel. Sine beta already is in terms of sine and cos. Plus. Eric, what am I going to write instead of tangent? Sine over cos. Sorry, Eric, what did you say? You're right. Say it again, please. Louder? No, the whole thing. The fact that you said over, if I have one fraction, I want everything to be fractions. No some fractions and some not fractions. That's dumb and confusing. All over. And since I'm now committed to fractions, I'm going to write everything as a fraction. If it's not, it's going to be a fraction over 1. What I don't want, Trevor, is a 3-level ugly fraction. I want a 2-level ugly fraction or a 4-level ugly fraction, but never have a... That's just silly. This is what we call a complex fraction. Why is it called a complex fraction? It's got 4 levels. It's got fractions inside of fractions, Joel. And there are various ways to handle this. You could, Spencer, write the top as a common denominator as 1 fraction. Write the bottom as a common denominator as 1 fraction. And then you would have 1 fraction over 1 fraction instead of 2 fractions over 2 fractions. And when you have 1 fraction over 1 fraction, you can then say, how do I divide by fraction? Flip it and multiply. That's about 5 lines, and it's doable. And there will be a few of you that will do it that way, especially those of you that are not from North America. But I would like you to master, to learn a wonderful shortcut, a wonderful, heck, I'll call it, Justin, a trick for complex fractions. And here is the trick. When you have a 4-level fraction, my goal, my path is now planned out. I want to get rid of this 4-level fraction, and the way I'm going to do this is I'm going to multiply the top and the bottom by the same thing, which means technically, Isabel, I'm multiplying the top and the bottom by 1. What's the same thing on the top and on the bottom? I'm going to look at all of the mini fractions, a 1, a cosine, a 1, a cosine, all of my mini denominators, and I'm going to find the common denominator for those. In this case, it's going to be 1, 1, 1, cos. If there had been a sine there, it would be sine cos. If there had been a sine squared there, it would be sine squared cos. But my common denominator is going to be the common denominator, Carly, of all the mini fractions. And here's how I'm going to show it. I'm going to put the top and the bottom both in great big brackets to remind myself that it's going to be distributing, or foil, or front door bomber, or whatever you called it in grade 9. I said I'm going to multiply the top and the bottom by cos, but I'm going to write it this way. I'm still multiplying the top and the bottom by cos, but since I have 4 levels, Mitsu, I'd like to keep 4 levels, please. Because clearly now, multiplying fractions, Trevor, that's the easiest of all the fraction operations. It's top times top, bottom times. And so I can clearly see what's on the top and what's on the bottom in the top. And what's on the top and what's on the bottom in the bottom. And I know I got multiple tops and bottoms here, which is why I'm going to be very careful. I'm going to go this times this, and I'm going to go that times that. Now, when I multiply this times this, there's a sine cos on top, and there's a 1 on the bottom. Nothing cancels, so it's just going to end up being sine beta, cos beta, over 1. Justin, now I'm going to drop the over 1, because I guarantee if I do this right, I'll go from 4 levels to 2 levels. Brett, what's right here? Oh, hey, what's this that just appeared? Tyson, is that this block? No, that's my other block. Okay. Note to self. Sleep for 1 hour. I'll have to get Tyson next block. Trying to sneak out of it. Don't think I don't have a long memory. Plus sign drops down. Plus sign drops down. Joel, this next one is more interesting because here I have sine times cos divided by cos. How many coses on top? 1. How many on the bottom? 1. And here's the key. How many left? None. I've got rid of my 2-level fraction on top. All that's going to be left behind is a sine beta. Also, I'm going to tell you that if you play your cards right, 99% of the time, you'll have a GCF. What is the GCF on this top row? Can you see it, Ellen? What's on the top over here? You know what? I'm always moving my eyes back and forth, looking for little breadcrumb clues. I think that's a clue. Okay. You okay, Ryan, so far? In the denominator, Ryan, will anything cancel with this fraction? Say no. Will anything cancel with this? This cos won't cancel that cos because it's on the top, in the bottom. Will anything cancel with this fraction? Say no. No. So, trick of the trade from Mr. Dueck. Don't write this down. Put your pencils down. Okay? If you did multiply this out, if you went chunk, chunk, you would go, well, let's see, I got cos beta plus cos squared beta, because I got a cos times a cos. Do you know what you would end up doing on your next line? Gcf and factoring. So if I want to give you a little shortcut, Alex, if you are getting rid of complex fractions, and you notice on one of your lines, Kara, nothing cancels, do yourself a favor. Don't actually bother multiplying it out. Leave it in factored form. Pick your pencils up. Write it as 1 plus cos times cos. Trust me. Because you'll end up factoring it on the next line anyways. Oh, and by the way, sorry, if you missed that, you are in no worse off because you'll just end up factoring it on the next line. But I'm trying to save you time wherever I can. All right? Get the hint sheet? What was hint 1? Okay, we did that. What was hint 2? Rewrite everything in terms of time code. We did that. What was hint 3? I didn't see squareds. When I say known identities, I'm looking for those top row of Pythagorean ones. I'm looking for squareds. Weren't any. What was hint 4? We're going to go with that. GCF on the top. And I'd have a cos beta plus 1 over. There would have been a GCF on the bottom if I had multiplied it out, but Justin, I was clever. Since nothing canceled, I said, you know what, just leave it in factored form. Drop the 1s. Can I cancel those? Well, first of all, look what I have on the bottom sitting by itself, Sandalee. Can you read that to me? What do I have on the bottom here? Hey, hey, hey. Look what I have on the top here, sitting by itself. What do I have on the top here? Are these two brackets identical? Can I cancel? Yes, I can. Most common mistake. Yeah, write it down. Becoming cancel loopy.
Say what?
You'll see something like this. And oh, Spencer, you will be tempted. Your heart will yearn. You will want to go like this. Wrong! It is. Can't do that. Those are not algebraically equivalent. They are not. And Ryan, I can give you a simple break, a simple checklist, a simple parachute, whatever you want to call it. I can give you a preventative medicine for this. Here's what you need to train your brain. If I ask, can I cancel? Question mark. If you ever say to yourself, oh, can I cancel these? Or if you ever say, I want to cancel these. Stop. First, ask, have I factored? If you have not factored, I guarantee you cannot cancel. Can I cancel? Have I factored? Can I cancel? Have I factored? Those two questions go side by side, Eric. By the way, up here, can I cancel? Did I factor? Say yes, Eric. Okay. Whereas, could I cancel this cosine with that cosine? Had I factored? Okay. Something like this, for example. Sine theta minus sine theta cos theta all over sine theta. Trevor, you will be tempted, oh so tempted to do that. Stop. Because you asked yourself, can I can't stop? Can I cancel if I factored? That question needs to be asked. Have we factored anything here at all? Have we done a GCF or a difference of squares or anything bracket-wise or anything like that? Vlad? Then before you go further, factor. Hey, how can I factor that top row? GCF. And you'll have a 1, a minus, and a cos theta all over sine theta. Can I cancel? Have I factored, Brett? That's legal. This mess simplifies to 1 over cos. I just made it up so I didn't know where it was going, but that's common mistake number 1. Common mistake Number two, if number two, hands in the wrong place, Mr. Dueck. Number two, there we go. If I can get rid of these two common mistakes, 90% of you will get to where you need to get. Maybe not in the shortest possible way. See, the problem is, Kara, as soon as you make a math mistake in an identity, you can no longer prove it because you've gone off the rails and there is no way you can make the left side equal the right side. Can't be done. And all you're going to do is do 15 lines where your pencil throws up on the page, basically. Okay. Common mistake number two. Multiplying by something other than 1. You see, Ryan, because we're doing a proof, we can't make the left side or the right side change. We can only make them look different. So if you're multiplying, the only number that doesn't change your answer when you're multiplying is multiplying by a 1. Now, it can be a funny looking one, Eric, like in the previous example where we multiplied by cos over cos, which is still a 1. But it has to be a 1. Example. Yep. Okay. Kids get something like this. Sine theta over cos theta plus 1. It would have been tangent plus 1, but I'm just skipping a step. Over cos theta over sine theta plus 1. And they say, oh, hey, Dueck says, make this a 4-level fraction. Oh, Mr. Dueck would be so proud of me. And then they say something like this. Well, I gotta, don't write, well, you're gonna write this down in a second. Let me walk you through the wrong argument, and then we'll write the word wrong next to it, and we'll do it correctly. They say, well, I got a cosine on the bottom. Let's multiply this by cosine over sine. That's great, because then the cos will cancel, and the sine will cancel. Oh, he says remember to do brackets. I'm not stupid. I'll do brackets, so I'll do that. What have you multiplied by? Cos over sine. Is that a 1? Here's the correct version. So we'll start out with the same complex fraction, which was sine theta over cos theta. And again, Brianna, it was probably originally tangent theta. I'm just making this up as I go. Plus, and I would have written it as 1 over 1, because if I have one fraction, I want everything to be a fraction. And then it was cos theta over sine theta plus 1 over 1. Oh, Trevor, is this a complex 4-level fraction? Then here is what you do. You look at each mini denominator, and you multiply the top and bottom by the same thing. And what's the same thing? The common denominator of the mini denominators, sine cos. See it, Spence? You're going to multiply the top by sine cos and the bottom by sine cos. But then, Spence, I said, do yourself a favor, make it 4 levels and 4 levels. That is a 1. So Ryan is not going to change your answer. It's going to make it look different, but it can't possibly change the value of your answer, because when you multiply by 1, you always get the same number that you started with. Ah, but watch what happens here, Trev. Here, can you see a cosine cancels? And I'm left with a sine squared. A sine times a sine. Plus, here, nothing cancels. I'm left with a sine theta Cosine. Thought you said when nothing cancels, don't bother multiplying it. That's if nothing at all cancels. I saw that a cosine would cancel, so I said it's worth multiplying out the top line. And I've glanced at the bottom line as well, and I notice in this first term a sine's going to cancel. In fact, I'm going to get this. Cos squared theta plus sine theta cos theta times 1, which is just sine theta cos theta. No, wait. Can I cancel? Have I factored? Don't you dare do what I just did. Oh, you're going to be tempted to, because then it's sine squared over cos squared. That's 10 squared. Oh, that's such a nice answer. No. Well, if I can't cancel because I haven't factored, you know what I should try doing, Mitsu? Factoring. Yeah, GCF. What do you see on the top, Mitsu? Sorry? You see a sign? I see a sign. And you'll get sine theta plus cos theta left behind in the brackets. GCF in the bottom as well? You don't say, really? Oh! Isabel, is that allowed? Can I cancel? Have I factored? I mean, the answer is yes, then yes. And in fact, I have sine over cosine. Oh, hey, what is sine over cosine? Plain old what? In fact, this whole mess that I started out with, that old ugly thing, turns out to be tangent. Those are the two most common mistakes. Caitlin, you got the hints for identity sheet there? Okay, hint 1, check. Hint 2, check. Hint 3, check. Hint 4. Oh, what was hint 4? Okay, check. Yeah, especially that and difference of squares as well. GCF and difference of squares. Hint 5, what was hint 5? Okay, have I done my little cancel loopy drill here? Hint 6. Complex fractions, we just done one. Finally, hint 7, which really was the point of today's lesson, except I wanted to brush the cobwebs off from 2 weeks of re-read. So, Caitlin, can you read to me hint 7, please? As a last resort, this is key because kids also, for some reason, go conjugate loop. Oh, I want to use it. It's as a last resort. Keep reading. Stop. It says, as a last resort, especially if you have a binomial denominator with no squares. Look at number 14. Binomial denominator with, I'm going to clip it. We're going to do it. As a last resort, especially when you have a binomial denominator with no squares. Keep reading, Caitlin. Okay. Here is the conjugate. The last and final resort. By the way, these 7 hints will get you through everything. And a bit of cleverness. So number 14, secant, that's a delta, for those of you who are scorekeeping Greek letters at home, plus tangent delta equals cos delta all over 1 minus sine delta. All right, now I'm going to solicit you for suggestions. So I say to you, suggestions, what should I try first? Okay, by the way, if you can do that, you can't possibly get 0 on identity. I give a half mark or even 1 mark for that. So identities, Vlad, they're nice in that they're tough to get 0 on. They're not so nice and tough to get perfect on. Oh no, wait a minute. I guarantee you'll get them. So I'm going to write secant. Secant does what? 1 over cos delta plus sine delta over cos delta. The right-hand side is already in terms of sine and cos, so woohoo! Okay. Anybody have another suggestion? There's something else I think now I would do on my next line, and it would be on the left-hand side. Combine them, since they have a common denominator, and I have one big fraction here, why not try writing it as one big fraction equals one big fraction? I mean, it's a start. So I would write this as, sorry, you'll notice I already have a common denominator, which is lovely. 1 over cos plus sine over cos is just all over cos, and it would be 1 plus sine. What was hint number 2? Rewrite it in terms of sine and cos. Hint number 3 was what? Look for known identities. Specifically, you're looking for squareds. Have I gotten these squareds? No. Hint number 4 was what? Look to factor. Got no GCF, no nothing, no nowhere. Hint number 5 was, what was hint number 5? I forgot. Oh, don't cancel. Hank, I got on the cancel anyways. Hint number 6, complex fraction. I don't have a 4-level fraction. As a last resort. You see how I get to hint number 7? Especially if, and I knew ahead of time, Justin, I have a binomial denominator with no squareds. Why with no squareds? If there was squareds, I bet you one of the Pythagorean ones at the top of the page would work. You can try multiplying the top and the bottom by the conjugate. And what's the conjugate? We walk over to this bad boy where this binomial denominator with no squareds is. Tyler, can you read that to me out loud? The bottom. Put it in brackets. The conjugate is 1 plus sine delta. Or if it had been 1 plus sine delta, the conjugate would be 1 minus sine delta. It's the same thing, but change the middle sign to a positive or the opposite. What did I say we always have to multiply by? What's the only number we're allowed to multiply by? A 1. Better put exactly the same thing on the top then. Now, by the way, Kara, can you read to me what I just introduced on the top? What do I have on the top over here? That can't be a bad thing. I mean, I'm nowhere near done, but at least I see a breadcrumb saying, good stuff. Okay. On the bottom, if we multiply this out, we will get 1 times 1, which is 1. We're going to have to do FOIL. We'll get 1 times positive sine, which is positive sine delta. Then we'll get negative sine times 1. We'll get minus sine delta. And we'll get negative sine times positive sine. Alex, what's a negative times a positive? What's sine times sine? On the top, I'm just going to drop this down. If I need to multiply it out on my next line, I will. But I have a feeling I'm going to want to leave stuff factored, and since it already is, why don't I leave it that way? By the way, what is positive sine? Take away sine. Yeah, those guys do cancel. That's not dividing cancel. I don't have to factor those guys. It's like adding the opposite. In fact, what do I really have on the bottom there? 1 minus Anybody got their nerdy adrenaline rush yet? Vlad, what? The bottom is actually cos squared, which conveniently I want a cos on the bottom over here. That's going to give me cos on... Really? You're saying that 1 minus sine... Oh yeah, because sine squared plus cos squared is 1. So if I hear you correctly, Vlad, you're saying... that... Oh, can I cancel? Did I leave the top factored cleverly? Then otherwise you would have to, if you had multiplied it out, your next line would be factor out the cos. But I left it. How many cos is on top, Vlad? 1. How many on the bottom? That, my friends, is the conjugate. Where would I use the conjugate? Looking back at this sheet, bet you on number 21, 1 minus cos. Maybe on these ones here, but since I have two fractions, I'm not sure. There may be a way to do it without the conjugate as well, but I don't know. Oh, probably on number 10, 1 minus cos. Okay. Do you want me to do one more conjugate one, or you guys feel that's okay? I've talked a long time. All right. So what's your homework? Two things. First of all, in the workbook, if you would like to turn to, and you'll be okay, I got another thing for you to work on, believe me. Turn to page 346, please. Page 346. Under the B, 3. Under the I, 4. Under the N, 6. I'd like you to do number 1, but skip A. Don't bother verifying. They work. Prove that they're unidentical. Prove it. Try number 2, but skip A. By the way, little hint. Number 2, how many different trig functions are there in this question? Only 2. Do I have a binomial denominator with no squareds? You could do that using the conjugate. Now you can, this is one of those ones where you can go either way. If you rewrite everything in terms of sine and cos, you'll get a lovely complex fraction here, and that'll get you there too. Either or. Three is good, except skip part 1. Don't bother typing it into your graphing calculator to see if it works. It works. Mm, 4C, 4D. (4E). 5, you're going to use conjugates. Okay. Then I have a lovely, lovely due the day of the test, holy smokes, lovely sheet for you. Let me hand it out. So, for years, heck, you guys get one? Yep. For years, heck, for decades, the last question, the last written question on the provincial exam was a trig identity. And I realize there is no more provincial exam, but for the final year that this course is running, I'm kind of running it that way. A few years ago, a teacher went through every single provincial exam, going back to like 1987, and lifted the trig identity from the end of each one, and put them into one lovely, fantastic, awesome, great, hey, if you work your way through this, you are in great shape review. This is going to be due the day of the test. This is one of your unit reviews for this unit. However, you can't quite do every question yet. What questions can't you do yet? What's right there, Sandali? Theta. What's right there? Theta. What's right there? That you can do this one. There are going to be a couple of questions, more than a couple actually, a few questions, where there is a 2 theta, like number 7. We call those double angles. I haven't taught you the double angle identities yet. They're on your sheet, by the way. Sine 2 theta, I think it's 2 sine theta cos theta. It's on your sheet. But anyways, you can't yet do anything with a 2 theta, so you can't yet do number 7. Can't do yet number 10 yet. Don't cross it out. You will be doing it. Or number 11. Or number 15. But you see, I'm just looking for a 2 theta. That's, you can't do those yet. 18, can't do yet. 20, can't do yet. 21, can't do yet. I also do have an answer key. So now apparently Microsoft suddenly decided to change the links or something like that. So this link didn't work for about 2 weeks. I fixed it yesterday. I was in Phoenix and I didn't have access to a computer that didn't automatically log me in and bypass the page that you guys run into when you click on my SkyDrive, because mine, it recognizes it's me and it takes me to a different page. Anyways, anyway. Click here. So I think it's working now. I hope. Uh-huh. And if you look under block A and under Trig, there will very shortly be this identities review and an answer key. As a matter of fact, I printed up a handwritten answer key. That was a thing at the beginning of class that said did not print. So I'm going to retry doing it right now. What's your homework then? Take home quiz and start working your way through identities. We're going to be spending a few days on this. Okay? Class is yours, humans.